One is complementary function and another is particular integral. So we followed the method of first order differential equation solution. Same method we have applied in second order differential equation. Find the solution of second order differential equation. The same method we have applied. Then we found that complete solution of second order equation is yc plus yp. C and P are mentioning the complementary function and particular integral, and that's found the second order equation has two roots. Everybody knows it. So they have two constants, C1 and C2, and the exponential form E R1t, E R2t, this type of terms. So overall, the solution becomes the C1 e to the power R1t plus C2 e to the power R2t plus e to the power R1t integration of e to the power R2 minus R1t integration e to the power minus R2t e to the e of t dt, overall dt. That is the particular integral part, this one. Okay. Now, if we look at this equation, this is the second order equation. So here has two roots. One is x equals to -3, another is x equals to -2. So in that case, the complementary function going to be C1 e to the power 3 minus 3t plus C2 e to the power minus 2t. Everybody clear up to this?
Yes, sir.
Yes,
Clear.
sir.
All right. Then, if we want to find out the particular integral, then we should have a function in the right side of the equation, such as the voltage Vs of t. Understand? So we just considering as an example that Vs is existed in the right side of the equation. So that in that case, the particular integral going to be e to the power minus 3t integration of e to the power minus 2 plus 3t integration e to the power minus 2t and Vs of t dt, overall dt. It's clear how R1 and R2 changes because of their roots value. Understand? So
Yes,
those
sir.
who could not attend yesterday, they can find the glimpse of the solution of second order equation in slide number 18, the last line. And here I have given an example in the on slide number 19, which has no right side function, but we can add voltage or current or whatever if we want to make it as a non-homogeneous equation. Understand? This was talked yesterday. Hope everybody understand, right? Now,
Yes, sir.
Yes, sir.
today, yes. Any question regarding that?
No, sir.
No question.
Okay, all right. So today we are going to start with the significance of solution of differential equation. That means why we are doing to find out the solution of differential equation. Basically, every equation has a meaning, right? Every equation has a meaning, but differential equation has a special meaning because that is changes respect to time. And derivative d by dt. D by dt is rate of change something, isn't it? D by dt is a rate
Rate
of
of change.
something.
Yes, sir.
So we can find out the physical significance from the differential equation. That's why we need to find out the solution of differential equation. Either it is homogeneous or non-homogeneous is not a matter. Look at the description. uh, complementary function, we can call the transient solution of physical problem. It means we have two states in any kind of circuit or any kind of device. They are transient state and steady state. In transient state, always the thing changes, response changes, but in steady state, response is stable, straight. Understand? State in the sense there could be some variation or tolerance, or you can say the ripple, but there will be reference value. Respect to reference value, it is changes very little. So we can consider that is a stable condition. But because the things are not changes until any fault occurs. Understand? So we have to remember the transient state is expressed by complementary function of differential equation, and steady state is expressed by particular integral of the differential equation. All right, you can see this example later on when we will have the circuit analysis problems. Understand? Beside this, you can find out in control engineering. In that case, it is clearly mentioned transient state, steady state, because we need to make a controller for stability of the system. So in that case, you need to study this transient state, steady state, fault condition, and some another modification. So many things going to be studied in control engineering course. Understand? So before that, you just remember that complementary function express the tangent solution, tangent state, and steady state is expressed by the particular integral. So now if we think the C1 and C2, how can we find out? Then we need to consider here always initially we consider that system is stopped, and if it is stopped, current or charge anything cannot be moved, so that cannot flow or move, so that we consider this time zero, means the things are flowing, the moving part is zero. So you can find out the C1 and C2 easily. Understand? So remember this complementary function importance and particular integral importance. Now here one circuit has been solved, which is a first order circuit, and everybody now understand how can you define the first order circuit, right? Is based on the storage element of the circuit. So since here has only one storage element, so definitely it's going to be first order circuit, but you have to prove yourself that to be confirmed, yes, it is first order, so that you can see the right side, the two equations based on the KVL. Based on applying the KVL in the circuit, we have found these two equations. One is R IL of t plus L DIL of t divided by dt equals to Vs of t. That means when circuit is closed, not at open mode, it's closed mode. All right. After rearranging, then you find the DIL of t by dt equals plus I R by L IL of t equals to 1 over L Vs of t. So from this second equation, you can find, yes, this is a first order circuit. All right. Now the question is, what is the solution of this circuit? What is the solution means? What is the current response of this circuit? That is the question. Solution of the circuit means the current response of the circuit. So if we want to find out the current of the circuit, then definitely, because here is why current, if you compare with the previous equation, there was written dy by dt plus something y equals to something like u of t. So here IL expresses the y, understand? So that the circuit current is the solution in this problem. So it has two parts, since there are two variables, one is IL, another one is VS. So we need to apply complementary function and particular integral formulas. So if we look at the complementary function, ILCU is identified as the IL of complementary function of IL equals to C by U. You remember, equals to C e to the power AT, right?
Yes, sir.
What is A? A is here R by L. Okay, R by L. So you can write directly that ILCU equals to C e to the power R by LT. Here it has explained. It has been explained here. You can look at. After that, particular integral is ILP equals to 1 over U. Can you remember the equation? 1 over U integration, U multiplication with the E of t dt. So since here U is the e to the power R by LT, so 1 over U is e to the power minus R by LT. Integration e to the power R by LT multiply Vs by L dt. That is a side note. You can look at the equation. After rearranging of the equation, we have found that e to the power minus I R by LT multiply Vs by L becomes the constant as a constant. Then e to the power R by LT, it should be the integrated. So we have found the 1 divided by R by L e to the power R by LT. Everybody remember the integration of
sir.
e to the power A t dt equals to 1 over A e to the power AT, right? So that formula has been used here. After that, cancelling out the L, we have and e to the power RLT and e to the power minus RL by T, they are going to be 1, right? Because they have the same base. And then becomes e to
Yes,
the
sir.
power 0, that is 1.
Or 0.
So ILP becomes Vs over R. Understand? That means the particular integral, as I mentioned, particular integral says it the physical problems steady state. So steady state, the current will be Vs by R. Understand? And complementary function says the transient state. So if you look at that, so C e to the power R by L t, it changes exponentially. So the final thing we can find out by applying that initial condition. By applying initial condition, we can find out what is the value of C. But before that, we need to find out what is the complement solution. So the complement solution of the current is summation of complementary function and particular integral. So we have found C e to the power minus R by LT plus Vs over R. Applying the initial condition, time is 0, so current flow 0 through the circuit. If you look at the circuit, then you can understand until switch on, there is no current. isn't it? So when switch on, then current flow and time starts. So before that, everything current and time zero. So if we apply initial condition, then we easily find out C equals to minus Vs over R, because T is 0, so it becomes 1. It's wait a moment. Hello, I'm in the class. Sorry. What is the name? Okay, send. Here, if you look at this initial condition, then we found the constant value minus Vs over R. Understand, everybody? Look at the constant finding method. Check yourself. After replacing the constant by minus Vs over R, the final current equation becomes minus Vs over R e to the power minus R by Lt plus Vs over R equals to Vs over R multiplied with the 1 minus e to the power minus Lt minus R by Lt. So this is the final solution. So if you put any voltage and resistance and inductance, then you can find out the solution of the given circuit. And the response you can find, what will be their response. In this case, we have seen this is charging mode, the energy storing mode, okay? So now you check yourself. If you can't understand, you can ask me question.
Sir, can you repeat please previous slide?
Previous slide, wait. This one.
Yes, sir.
Okay, where is your question?
Sir, complementary function.
Complementary functions. To understand this one, you have to go back the first order linear equation. This one. So if you look at this equation of complementary function, C by U, where U is the integrating factor, e to the power A0t dt. If you go back little bit, how A0 coming, if you look at this equation, given equation, then you can find out the where is A0. Understand?
Yes, sir.
And particular also, in particular integral also, you can see from here, this is the general equation. Whatever equation value is given, is not a matter. If you follow this formula, you can find out the solution. So complementary function, you see this formula, remember, and let's go to the problem. Let's move to the problem. Near here, the C by U, and it's A. How A got? A0 is becomes R by L. Understand?
Yes, sir.
Just change
Yes,
the
sir.
A0 value. Then you get this complementary function. Clear?
Yes, sir.
Any more question?
No more questions, sir.
Okay, if no question, then I will ask that have you studied the inductor energy storing and releasing curve? Have you studied energy storing curve?
Yes, sir. We studied.
Then tell me, how can you understand this is energy storing mode or releasing mode? Definitely of a inductor. Inductor energy storing mode and releasing mode. How can you understand? Yes, Jim. Jim,
Hello.
yes, can you answer the question?
I can't hear. Hello.
You can't hear. How can you understand energy releasing and storing mode of a inductor? Can you answer?
What's happened? Sir, inductor motor releasing the energy, sir.
Yes.
Sir, on this curve, sir. Hello.
Yes.
What happened?
But
My
you have
name.
studied the energy storing mode and releasing mode of inductor in circuit 2
Yes, sir.
or
Yes, sir.
circuit 1.
Sir, but
You remember those things, that how can you understand?
I didn't know, sir. Actually, maybe I
Okay, all
forgot.
right, no problem at all. Just remember the current shape. When current is rising, that is energy storing mode. When current is decreasing or falling, that is energy releasing mode. Understand? Similarly, in case of capacitor, if voltage increasing, then it's charging. If voltage falling, then discharging mode.
Discharge.
Yes. Now you will see the another things, another problems that is more interesting, very interesting. Second order differential equation and second order circuit. This is very, very interesting and very complex. I have mentioned you, if there is no complexity, then there is no interesting things. So look at the circuit, then you will understand how it is interesting and how you are uh, solving this second order circuit by applying differential equation method. Hello, I'm in the class. I'm in the class. Look at this circuit diagram in which L and C are the storage element and R is the consumer element. And switch is off at T0. So at off mode, there is no current flow through the circuit. Understand? So firstly, we have to apply that KVL, and by seeing the KVL, then you see this equation that R IL plus L dIL by dt plus 1 over C integration of IL tau d tau equals to Vs. Understand? Vs. So if we do both side differentiation, then we will have di square IL by dt square plus R by L dIL by dt plus 1 over LC IL, right? Equals to Bs by L. Is it okay, this line, this equation? The third equation is all right?
No, sir.
স্যার এল দিয়ে ভাগ
Can
করছে
you explain it again?
Then what will be the correction
এটা কি 1/l দিয়ে গুণ করা হয়েছে স্যার থার্ড ইকুয়েশনে?
Yes, the L has been used as a divisional component. The third line, is everybody agree this line is correct or incorrect?
Correct, sir.
Correct.
Divided by L. 1 by L.
First to second order integration, then
Which line, sir?
Third line.
Third line.
Yes, sir, it is okay, sir.
স্যার ইন দ্য থার্ড লাইন আর বাই আর ডি আই এল এল ডিটি স্যার এটা একটু
The third line is divided 1 by L.
This is third line. The equation is all right, or any mistake or anything?
In the right side, I think sir, it's 0, sir. Hello, sir.
I think you did not study my lecture sheet. I have sent you in the first day, on the first day, but you did not look at all, I think. I always say, since it is an online class, before coming the class, you should look at the lecture sheet. And also in my lecture sheet, there is a written, check yourself. Every slide, it is written, check yourself. That means you should study. If you cannot find the problem in the class, then you have to come in the consultation hour. And consultation hour.
স্যার ইন দ্য থার্ড লাইন
Yes.
স্যার ইন দ্য থার্ড লাইন Hello.
Yes, third line. Tell me, what is the problem?
So in the third line, RDIL by LDT. So how come?
This
Yes,
one?
sir. Yes, sir. Yes, sir.
Second line first.
Think. I have told you just a minute before that how it
Explain, sir.
comes. Maybe you did not listen. Think yourself, because engineers should be very smart. Whenever look at something, they need to guess what has been done here. Otherwise, how they will investigate or the survey some sites or design a particular things. Look at this simple equation, because this equation has been used several times. Whose mic is on? Can you stop mic if you don't talk?
Sir, I got the problem, sir. Sir, there is a IL, there should be IC, sir. And 1 over C integration of IC tau dt. So there will be IC, sir.
Another student?
Sir, I think there's missing, sir, d by dt, sir, in the right side, sir.
What? Raise your voice. Raise your voice. I can't hear you.
Sir, I think there is a d by dt missing, sir, in the right side, sir.
D by dt in the right side
Yes, sir. Yes, sir, in the right side, sir.
is missing.
Yes, sir, I think, sir.
You are close. Okay. Okay, all right.
There might be, sir, 1 by L d by dt of ds.
Okay. Yes, that's true. This is the
Yes, sir.
right things, that should be d by dt into 1 over
ds
L.
divided by L, sir. Yes, sir.
So at least eventually you answered, that's fine. Very smartly you have to answer. Then since we have found the second order differential
Then
equation,
we can say this, sir.
here the things is that the second equation has been
So we
has
can
been
say that,
derivative once more. Okay, so L d I L by dt, if we do once again the derivation, then it becomes d square I L by dt square, isn't it?
Yes.
And RIL becomes RIL becomes RDIL by dt.
Yes, sir.
Sulaiman, I am in the class. Tell me shortly what is the problem. So in here you can see R dIL by dt, and second term becomes L d squared IL by dt squared. And here is the integration. Integration will be cancel out by differentiation. Understand? And d by dt Vs. D by dt Vs. Understand? So after that, we have taking out the L to make d square IL by dt square free coefficient free. All right. So that we have made this equation like that way. Firstly we did the differentiation. After that we taking out the L, so that the equation becomes d square IL by dt square plus R by L dIL by dt plus 1 over LC IL equals to, it should be d by dt Vs into 1 over L. However, this Vs is constant. So d by dt of constant becomes 0. Here is the 0. All right. Okay, taking break 5 minutes and think
Okay, sir.
yourself. I have another student to accept.
Thank you, sir.
Do you have any information?
No, sir.
Okay.
No, sir.
One student had called me. Let me check.
So once you join, then later we